So, if we just looked at A rock and I rock, then you'll notice that my example there was kind of foreshadowing something that might be coming. I want to discuss what happens when you take the derivatives of a position function. So, a position function tells you where something is located. Maybe I throw something up in the air and it tells me how many feet off the ground it is. Maybe it's a race car zooming around a track. Maybe it is your parents stalking you on GPS because they have your phone sensors on and they can figure out where you are located. But what I'm interested in, usually position is in some kind of distance or measurement like feet or miles or furlongs, I don't know. Okay? So what happens when we take the derivative of distance? We are going to take it with respect to time. So basically, we are taking the change in distance over the change in time. Now, those of you who have taken any science classes might have heard of this thing before. It's known as, so if you haven't heard of this before, the change in distance over change in time is called the velocity. You can find the velocity of the object if you know its original position function and you take the derivative. For example, this was supposed to be the height of an object. Now, for those of you who have taken some kind of physics, you might know that this is 1/2 at squared plus v sub o t plus h sub o. But if you don't, it doesn't matter. What it means is that in 1 second, I can plug 1 in here and I get the velocity of the object. It's still going up. If I plug in 2 seconds, now I've got the velocity of this object and it's negative, it's going back down. If I found just the right point when I'm throwing an object up in the air where it hits the highest point, what is the velocity at that one moment before it starts coming back to Earth? 0. So, the derivative of any position function is velocity. And now, of course, my next question is, what is the derivative of velocity? A change in velocity over a change in time is called the acceleration. How fast your velocity changes is your acceleration. Darn it, I seem to have wrote that right on that bright mark. But it's the acceleration. So the second derivative of a position function is the acceleration. And for anyone who's studying physics, of course, when you throw something up in the air, the acceleration due to gravity is negative 9.8 meters per second squared, approximately, not exactly, sorry about that. So, given any kind of function, like this one right here, it's pretty lame, but one of the favorite choices of problems for books and or the AP exam is, a particle is moving along the x-axis. Its position on the x-axis is given by this function. But if you're given that position function, how do you find the velocity? You take the derivative. And taking that derivative tells you how the distance is changing, how the position is changing. That's what velocity really is. And then, of course, I'm going to ask you next to find the acceleration. And yeah, you can call the acceleration either the derivative of the velocity itself or the second derivative of your starting function, your position function. So that's position, velocity, and acceleration. There are a few more of these, which is a little odd. Probably won't be asked about them, but just in case. That's right, there's something called jerk. The change in the acceleration over time is jerk. And there are some engineers who need to know this. When you're making parts for something, how quickly something accelerates could have a great deal of impact on the force exerted on that part for just a moment as it is changing. So jerk is important, but snap, crackle, and pop are absolutely not important. I can't think of any actual use for them in the real world, although I'm sure there probably is somewhere. Maybe theoretical, maybe real. But some mathematician or physicist a long time ago thought it would be real funny that once we take and look at the change in jerk over time, they call it snap, crackle, and pop, after our favorite Rice Krispie treat characters, snap, crackle, and pop. Thank you for your participation today, and I hope you've learned bunches of stuff.